Hello, and thank you for your interest in understanding more about the condition of natural resources in the parks of the National Capital Region of the National Park Service, which I'll call in this video NPS. My name is Katie Mae Lauman, and I am a project manager at the University of Maryland Center for Environmental Science Integration and Application Network, or EAN. Our logo, along with the National Park Service logo, is on this slide. In this presentation, I'll discuss the Resource Assessments for Management Strategies project, which we call RAMS for short. RAMS is an ongoing collaboration between EAN and NPS that assesses the current conditions of natural resources in the parks. This is one of several videos about RAMS. Today, I will introduce you to the project, discuss how we assess water quality, and speak briefly about what these assessments mean to the NPS when managing natural resources. On this slide, there is a map of the National Capital Region that shows parks in and around the Washington, D.C. area, including Maryland, Virginia, and West Virginia parks. Parks are shown in purple, and other colors indicate the types of land cover surrounding each park, including forest, agricultural, and developed land. There is also a list of the 11 parks that are included in RAMS: Antietam National Battlefield, Catoctin Mountain Park, Chesapeake and Ohio Canal National Historical Park, George Washington Memorial Parkway, Harpers Ferry National Historical Park, Manassas National Battlefield Park, Monocacy National Battlefield, National Capital Parks East, Prince William Forest Park, Rock Creek Park, and Wolf Trap National Park for the performing arts. On this slide, there are 4 icons that represent the categories of natural resources assessed and summarized in RAMS. A water droplet represents water quality, trees represent landscape dynamics, a swirl represents air quality, and a fish, deer, and leaf represent biotic integrity. The NPS Inventory and Monitoring Program has measured indicators in each of these categories for more than 15 years in the parks, and they'll continue to monitor in the future. Today, we will focus on the indicators of the water quality category. First, I will use one water quality indicator to explain generally how natural resources are assessed in each park. Here is a picture of rocks in a shallow stream. We assess various aspects of water quality, including indicators of water chemistry, living things, and habitat. The condition of these indicators, listed here, are used to determine the overall condition of water quality in each park. Indicators dealing with water chemistry are temperature, pH, dissolved oxygen, specific conductance, and acid neutralizing capacity. Indicators that tell us about living things are total phosphorus, nitrate, and benthics. Finally, we measure one habitat indicator. This slide shows a table listing the 9 water quality indicators, along with columns called reference condition, park average, overall score, and condition. I will step through this table to understand how indicators are scored. We've selected a reference condition from the scientific literature for each indicator, which is the target condition we compare park data to understand if the condition is acceptable or degraded and unacceptable. This is illustrated in the reference condition column, which shows a color gradient from red to dark green for each indicator. Numbers below each gradient indicate scores. A score of 0% is at the red end of the gradient, and a score of 100% at the green end. Numbers above each gradient indicate the target condition for each indicator at the green or 100% score end of the gradient, and the condition at which the indicator is very degraded at the red or 0% end score of the gradient. Scores are generated based on how close current conditions are to the reference condition. I will use the total phosphorus indicator to show you how the scoring process works for a hypothetical sample park. For RAMS, this scoring process is applied to each indicator in each park. When we look at the reference condition for this indicator, the target reference condition is an average of 0.01 milligrams of phosphorus per liter of water. If there is 0.01 milligrams per liter of water or less in a stream, the indicator receives the best possible score, 100%. Higher amounts, like 0.09 or more milligrams of phosphorus per liter of water, are considered very degraded conditions. So if phosphorus concentration equals or exceeds this value, the indicator will receive a score of 0%. Values in between 0.01 and 0.09 milligrams receive a score along the scale from 0 to 100%. Moving to the park average column, we see that in the park we are scoring, the average value is 0.02 milligrams of phosphorus per liter of water. To generate a score, we compare that value to the reference conditions. Because 0.02 does not meet the reference condition for a 100% score, it is scored along this scale from 0 to 100%, receiving an overall score of 84%. In the final column, called condition, there is a green circle followed by the text very good. We use stoplight colors, which are green, yellow, and red, to convey conditions. In addition, we have light green and orange for in-between scores. The stoplight colors, shown in boxes on this slide, are accompanied by letter grades, associated score ranges, and overall condition descriptions. Dark green corresponds to a score range of 81 to 100% or a letter grade of A. This is the best a park can do to meet the target reference condition. Indicators within this range are considered to be in very good condition. Light green corresponds to a score range of 61 to 80%, or a letter grade of B, which is considered good condition. Yellow corresponds to a score range of 41 to 60%, or a letter grade of C, which is considered moderate condition. Orange corresponds to a score range of 21 to 40%, or a letter grade of D, and degraded condition. And red corresponds to a score range of 0 to 20%, or a letter grade of F, failing to meet reference conditions and considered to be very degraded. The overall condition of the four categories and their measured indicators are placed on a wheel, which you will see on the next slide. On this slide, there is a wheel cut into four large wedges representing the four categories of air quality, water quality, biotic integrity, and landscape dynamics. Three of the categories are gray. The other, labeled water quality, is divided into smaller wedges and stoplight colors labeled with the names of the water quality indicators. The colors of each indicator correspond to the scores I just explained from the sample park. For example, assigning a letter grade and color to total phosphorus resulted in a score of A. In the wheel, this indicator wedge is shown in dark green and listed with a score of A. This reflects the results of our earlier scoring process. Total phosphorus is in very good condition. Moving on to the other indicators, nitrate, acid neutralizing capacity, dissolved oxygen, and pH also received scores of A and are in very good condition. Temperature has a score of B. It is shown in light green and is considered to be in good condition. Benthics and habitat each score a C and are shown in yellow, corresponding to moderate conditions. Specific conductance is red, failing to meet the reference condition and considered very degraded. Next, the scores of each indicator are averaged together to create one summary value for this example park, which gives water quality an overall score of B. The category color band around the indicator wedges is dark green, meaning that overall this category is in good condition. But what exactly do these indicators measure? Why are they important? What do they mean to us and to park managers? Water temperature strongly impacts the species that live in park streams. Many species, like the brook trout on this slide, require specific temperature ranges to survive, stay healthy, and successfully reproduce. Fish are particularly sensitive to temperature, and the temperature threshold for this indicator is based on the optimal temperature ranges for cold water adapted brook trout and other fish in NPS streams. pH is also important to aquatic species and affects all life stages in freshwater, food, and toxicity of chemicals. It is a measure of how acidic water is. Fish and salamanders are particularly sensitive to changes in pH, and thresholds for this indicator are based on optimal pH ranges for animal life, growth, and reproduction. This slide shows a picture of a small waterfall. Low dissolved oxygen is detrimental to aquatic life. Animals, including fish and other aquatic animals, need oxygen to survive. The concentration of dissolved oxygen in water impacts survival and growth. Dissolved oxygen can become too low as a result of high temperatures, stagnant waters, pollution from stormwater runoff into streams, and the ongoing decay of organic materials like leaves or dead fish. This slide has a picture of the Monocacy River. Specific conductance measures water's ability to conduct electricity, which also indicates the salinity of stream water. Aquatic animals can be sensitive to specific conductance. Specific conductance outside of the optimal range can be indicative of pollution, excessive human disturbance, and decreased habitat quality. Here is an image of mine tailings entering a stream. This image is not from a national park. Acid neutralizing capacity measures how well water can buffer acid inputs like the mine tailings shown here, and prevent wide swings in pH values. Streams with higher levels are affected less by acid rain and acidic pollution than streams with lower acid neutralizing capacity values. This slide has a picture of algae overgrowing in a body of water. Nitrate and phosphorus measurements reveal nutrients or chemicals in water, which impact algal growth. Both nitrates and phosphorus are nutrients that are essential to all plant and animal life. When amounts are too high in stream water due to pollution, they disrupt aquatic ecosystems. Excessive nutrients can cause explosions of the growth of plants and algae, resulting in the loss of animal life due to a lack of oxygen dissolved in the water. Common sources of pollution causing excessive nitrate and phosphorus are fertilizer or sewage running into streams. The Benthics indicator assesses the condition of benthic macroinvertebrate life, like the crayfish shown on this slide. Benthic macroinvertebrates are invertebrate species that live on the bottom of streams and lakes. These species are more or less sensitive to various kinds of pollution. This indicator is based on the Benthic Index of Biotic Integrity, which evaluates the number and diversity of these creatures in a stream. This slide has a picture of a stream. The habitat indicator looks at overall stream condition and how well it supports aquatic life. It is based on the Physical Habitat Index, which measures various aspects of stream habitat, including the stream bed physical complexity of rocks and riffles, amount of shade from vegetation in stream banks, and stability or erosion of stream banks. Revisiting the score wheel, note that the indicators we examined, while related, tell us important information about various aspects of water quality within a park. They all come together to give an overall snapshot of the condition of this category. This is based on NPS inventory and monitoring program data. We can recalculate park scores whenever new data is collected. These scores can help guide managers in identifying what indicators need the most management focus. In our other videos, we will discuss the 3 other RAMS categories: biotic integrity, air quality, and landscape dynamics. We will introduce the indicators that the NPS Inventory and Monitoring Program and the Resource Assessments for Management Strategies project assess for each of these. Thank you.